Hey, what's going on, everybody? Welcome back to agronomy here at CTC. Today we're going to try to talk about, discuss harvesting of crops and what that looks like. Now, we could spend days and years on this subject, just like with every other subject. But just once you get a good understanding of what goes into it, what we think about, or what farmers think about when they do go to harvest. So when we talk about harvesting, harvesting is basically, by definition almost, it's basically the completion of a production cycle. So where we have a product and now we can actually harvest that product out there that's in the field. And now this also provides, when we harvest, we actually are harvesting or providing a commodity that we can then market and try to provide a way for us to get income for the actual farm. So once we have it, we have a product, which is also a commodity, and then we market it, and then we have income for the farm. But after crop harvest, we must remember that all crops need to be stored in some form or fashion. Today I listened to the 6 o'clock radio station I normally do, and they said they sold 200 bales of cotton. Now, they haven't harvested cotton in probably 3 to 4 months, but they slowly sell that cotton over time through warehouse stations throughout the U.S. Now, let's start off with grain crops and how we harvest them. So basically, it's when the plants are fully mature. That's when the seed or the crop itself is actually fully mature and typically hardened and dried a little bit. And we typically allow some of those crops to dry actually on the plant out in Mother Nature. Saves a lot of cost. It helps with storage life, things like that, and we'll talk about those going forward. But we harvest them, most of our grain crops, using a combine typically. Sometimes we'll bale them up, sometimes we'll use them as a forage crop. Just kind of depends on what the goal is at the end of the day. But those are some things we're going to try to talk about. Now, if we look at the physiological maturity of grains, and this is basically when the maximum accumulation of dry matter in a seed occurs. So once we take all the water out, that's when that plant has the most amount of material on it, or in it, or the whole plant, depending on what we're trying to do. So we try to look and see what's out there, and we can kind of figure out where they're at. So here's some examples of what some producers try to look for in different grains. And sunflowers, the color will change from a green to like a brownish color. If we look at soybeans will go from a green to a more yellowish color and then a brownish color. If we look at a milk line in a corn, so if we look at the actual leaf of the plant, it can tell us quite a bit. But as we're trying to figure out when to harvest, so here we have a graph of what we're going to consider oats, and this is pretty much the same. The numbers would change on the axes on this chart, but it still gives us a relatively idea of what's going on out there with most crops. So if we see the purple line is the actual days after flowering. So, as we follow that, the plant's flowered, so it's went through its sexual reproduction to produce that seed, that germplasm, and then it goes up, and we see that. And we also see there's a relative line over on our right hand side of that graph that talks about the percent seed moisture. So after they flower, it'll drop. Now, if we also look at seed moisture, seed moisture drops after flowering. And as it starts to fall, and once that plant flowers, that's pretty much the almost the most amount of moisture that crop is going to have in it at that time. From there, it's going to lose moisture until we harvest it to the right to what we actually need. And we actually see that the seed weight drops as moisture leaves, and that makes sense because we're basically dehydrating it for the most sense, so we can store it for long periods of time. So when we were talking about drying of grain harvest, of the actual grain before harvest, we really do that to design to help produce the seed that is less susceptible to microorganisms. If we think about microorganisms, bacteria, fungus, they need moisture to live off of. So if we dry that crop as dry as we can get it, and we can even supplement dry, and we'll talk about that, we lessen the risk for the mold and any spoilage that can actually happen. So, but if we think about it, physiological maturity of grains, it's not dry enough at that point in time for storage. It must be dried further. Now we have a lot of options. We can hang it in the field on the actual plant still and harvest it later. Let it get down to right moisture content. Then we have all heated dryers. We can put air on it through a big fan within our grain bin systems. But as our increase in air temperatures get higher, we have higher airflow and decreasing humidity. These all increase water loss. So if we think about corn and where we're currently sitting, or should be sitting in class, once we get that plant to about the middle of May or even June, that plant is pretty much done growing. It hits the full maturity, and then we get hot temperatures. Typically we get some winds coming out of the south off the coast. Our humidity drops a little bit, especially in the middle of the day. We get a little more humidity in the evening because of cooling effects, but we're still pretty warm even during the evening times. And all that helps us dry out the crop on the plant itself. But now as we go to harvest it, the moisture content of the crop, of the grain, it can be combined, so we need it to be pretty dry. That's actually it. On the cob itself, of the ear of corn, the cob is in the middle. All the kernels are attached to it. As it dries, it helps loosen up those kernels a little bit to make it easier to remove the actual corn. So we can harvest grain or corn when it's about 25% moisture. Now, we have to dry it at 25% for us to store it for a long period of time. So in a common world, most farmers around here, they're going to harvest it in a local area. They're going to harvest it around that 15 to 14% humidity, or excuse me, I'll start that over. We're going to harvest it about 15 to 14% moisture content, actually in the seed, the crop itself. Worried about just the kernels because that's the only thing we're going to really store. But if we look at soybeans, we can harvest them at 13%. And our small grains, we can swath them before actually they get there, so we can go through and cut it, lay it down in windrows, almost like we're producing a hay. That we'll talk about later, and then we can run it through a combine in that aspect to do it. So we have a lot of options depending on where you are and what your temperature and your weather does. So up north, Nebraska, Kansas, they may harvest that corn at 25% because they may be looking at a big snowstorm coming in, and it's going to be better to get that crop off. Now, I have heard some farmers that actually waited for the snow to come, for it to melt, and then for a hard freeze to hit, to make the ground hard enough they can run their equipment through, and then they go through and they actually dry it from there. I'll show you a picture of what a big, large commercial dryer actually looks like. So if we look at some field losses at several grain moistures for soybeans, We have two lines. The red or orangish colored line, that's the total machine loss. That's how much we actually get from just the loss of harvesting over an entire field. Um, Now the purple line is the shatter loss. That's when any type of grain actually breaks through the actual process. So one of the next diagrams you're going to see coming up here in a minute is actually a picture of a combine, and I'll explain what happens in that shuttering process. But basically, those kernels, like in corn sense, would actually break, and then that's a loss that we can't really market as most people want to buy. But as we see our moisture content, the axis on the bottom, as it decreases, we definitely have more shatter loss because moisture kind of holds stuff together and makes it a little more soft and pliable. And we have a lot more machine loss because it makes the kernel or the pod heavier, so it doesn't blow it out the back, because the machine has a big blower that blows a lot of trash out, and we'll talk about that going forward. And then we also see that the line, that we have a loss in poundage of soybeans. If we look on the left-hand axis of that diagram, we actually see that we have a loss of grain in pounds. So basically, we lose a little bit of weight. So there's a perfect line in there that we really try to hit when we're trying to harvest our crops and try to get the maximum we can for maybe marketability, especially if we're selling directly out of the field or straight to an elevator. So when we talk about the different methods of grain harvest, all grain crops are harvested by combining, running it through this big machine we'll talk about here in a minute. And combining basically cuts, it gathers, it threshes, and it cleans the grain all in one time. So very big, complex machine. But the crop residue, the straw, the leaves of the plant, and stover, or some of the chaff, we could also call that, it's actually discharged from the back of the combine, and I'll show you what that is here in a minute. And if we look at the residue can be left on the field, or we can pick it up for baling. Some people will bale like corn stalks or wheat stubble, wheat straw. If we think about the mushroom industry actually requires them to mix like cow manure as well as straw to get the right media for them to be able to grow mushrooms. So it's a byproduct of the wheat industry, but it's a way to get more money out of it, get some more money out of your crop. But there is a flip side of that. You take any plant material off, you're taking nutrients off. So that means you're going to have to also add fertilizer to it, more fertilizer next year. But if you have a cheap source of fertilizer, it may be a great way to make another little bit more bang for your buck. So as we look at this picture right here, this is a diagram of a combine, a little bit older type combine. If you see one now, if you Google it, you're going to find a newer model, a little bit different. But this machine right here is really trying to set up, for the most part, because of the way it's cut, the header up here in the front. This is where we actually gather the combine. So everything enters here and comes out the back, essentially, or it comes up here in the grain hopper. So this head is for gathering, is for cutting or gathering like wheat or oats, maybe some milo, things like that, or soybeans as well. Corn headers, and I'll show you a picture one later. But here's what we consider the cylinder and the concave. So basically what happens is all the stuff comes in here. It gets sifted through just a little bit. Some trash goes out. But as let's say we're taking wheat in here, the wheat tumbles around here. And what happens is it kind of thrashes the head, and it breaks the seed loose from the actual plant. And as it does that, it's going to fall down. There's a set of screens right here. Those screens are going to try to filter out some big things and some little things. But mainly, in theory, we really only wanted to screen out kernels of seed to come down here into this auger process. And so what happens is, once it falls down through this screen, big stuff or little stuff, typically it should be little stuff. Big stuff should be pushed out the back and come out right back here on the back side. But we have a fan system right here. It's going to fall, the grain is going to fall down into this auger, is what this is right here. And this auger right here is going to take it down here. And these are what we call sieves. And so it's going to take out some more smaller particles, just a finer grain. And you can either adjust these, or you can get ones that are made just for one crop. But usually they're adjustable, because even within a crop setting, your variety, big kernels, small kernels, we still adjust them a little bit. But these fans right here actually blow air up to blow out all the really light stuff. So like the chaff, the things that aren't grain crops, but they made it through all the filters essentially so far. And then those blow out the back. Now, if we have really light grain, this fan can actually blow some light seed out the back as well. So that's one thing we need to keep mindful of, is this fan speed is adjustable. We can turn it up or down, but if we turn it up too much, we could blow some perfectly good crop out the back, and then we have volunteer crops and bigger issues that we've talked about before. But up here, we actually still have some more sifting of the big stuff, getting some more of that grain out, and it all comes down here, and then there's an auger that typically brings it all up here into a hopper. This is no more than just a storage unit for the crop while the machine is running. And there's typically a big old arm that comes out that's an unloading auger, and dumps it onto either what we consider a grain buggy, just a grain cart, just a way to move stuff throughout the field so we can maximize this machine running. Or not. So if you got any questions on that, feel free to, there's a ton of videos on YouTube about it. I don't mean to tell you to push you to YouTube, but there's a lot of great information about how these machines work out there. And these machines, this is an older machine, like I told you, because of the cylinder here. Some of them are rotary axles, so it's a big long cylinder right here, just redesigned, maybe newer edition of it. But they both do the same thing, just different ways of skinning the cat essentially. So here we have a combine, John Deere combine set up for harvesting soybeans. So the diagram we saw up there just previously, this is the kind of header it has. So this is what we call the reel right here, and that just turns in a circular fashion that helps pull the crop actually onto the header. So this thing is basically, it would be spinning towards you if you were standing right where this picture is taken, and there's little fingers, and it just gently pulls the crop in there so it won't fall out of the actual header. Just pulls it in there, and there's actually a set of sickle bar cutters, so just a set of scissors down there that's cutting the stalk off at the ground. So this is previously harvested area, and this is unharvested area. So it's going to take all this plant material through that machine and out the back. Now here we have a combine set up for corn. If we see each one of these little areas that I'm pointing to with my mouse right now, hopefully you can see that, you put every row of corn in one of those, and there's some fingers in there on some chains that, as the stalk pulls through, the ear of corn is going to stay on it. It's going to stay on the machine, and then it's all going to go through the middle of the machine and go through the same process that we've talked about before, and then all the trash goes out the back. Everything goes up here in the storage container, and then it goes out this unloading auger into this truck right here. And then it goes to the mill or to the granary or wherever it's going to go to its final use. So our next, we talked about drying of grain for storage, and this usually, grain usually is marketed at a certain bushel weight and moisture. So for corn, our bushel weight is 67 or 56 pounds. Is what we consider one bushel. So in the industry, you'll hear them say, well, so many bushels of grain. Well, you take however many bushels times how many pounds of corn, or how many pounds of corn are in a bushel, and you times that. So 1 bushel of corn equals 56 pounds. And the grain, because the grain moisture is so critical for the storage aspect of things, up north where they may have to harvest it a little greener, about 25% on corn maybe, we need to try to drop that down a little bit to that 14 and 15% mark for it to store very well. But so we can do a couple of things to reduce it, reduce moisture. Is we can field dry it. So basically we just leave it on the crop. We take more risk because it's just going to sit there, right? We have a larger possibility of a storm coming through and knocking our crop over where we can't harvest it, or wildlife getting to it. There's a lot of things that show up. Or we can artificially dry it. Now the cost of this goes up drastically, but it's really good for some high value crops. And what you're seeing right here, this big gray chamber, we put corn, we put any crop in here, and we see this big gas meter. Well, we actually heat it and we take a lot of moisture out, and there's some fans and there's some big rollers in there that just keep moving it around like a big clothes dryer essentially, and we can lower the percentage of moisture in a crop so it stores a lot better. You see this a lot up north, or where they might get into buying, they have to harvest because the weather's come in or things like that. But in our part of the world, we don't dry a whole lot of crop. We let it dry out in the field. We're very fortunate in that aspect, and we just take it day by day. Now, if we talk about grain storage, goals should include maintaining the color, or the quality of it, which is color and the purity and the odor of it, because odor is a big thing, especially on the livestock side of things. If it's rotten, animals won't eat it typically. And the viability, if it's to be used for planting. So if it's a good crop, we want to try to use next year for seed, because that's how we produce seed, just by growing a crop essentially. We want to make sure our grain storage is on point and we don't damage the germplasm in there. But we look at the temperature, the moisture, and the storage time to determine storage losses, because you're always, if you store it, you're going to have some type of loss, because you're going to handle it one more time through a set of augers. You're going to have some more kernels that are broke off, and for lab, you're going to watch a video on how they actually grade some grains. And go through that entire process, and then I'll ask you a few questions about that. But fungi are the most frequent cause of loss. So there's some fungus that happens in there that basically just it messes with the color and the odor, and how pure it actually is. So that's a really big thing. And then we have insects. So there's a weevil. You heard about the boll weevil before, but there's actually a little bitty weevil, smaller, black in color, that'll actually, and all it does is it bores through and it eats the germplasm, the good stuff, out of the actual kernel itself, and leaves the hull there like nothing. And so where a kernel may, let's say for instance, these aren't real numbers, but let's say a kernel would weigh an ounce, it'll take it down to half an ounce, because they take everything on the inside out. Rats and mice, they can also be a problem, where they defecate, urinate. You can't use that. Or you also worry about the amount of grain they actually consume as well, if there's a real bad problem with it. But if we look at harvesting forages, we can harvest our forages, our plants, that we just for our livestock animals. Now, in a perfect world, the best way for us to harvest grass is for directly by livestock, right? We let them convert that grass into a product, a meat product or milk product, and then we market it from there. But sometimes we need to be able to feed stuff maybe in a confined feeding spot, or even when it gets really dry, maybe in the summertime or in the wintertime when we don't have any green forages in our part of the world. We can harvest mechanically and we can produce hay or silage, and those are two different totally things, and we'll talk about those coming up. But a lot of times, when we harvest any of our crops, we don't there's really not a whole lot of mature seed on there, because usually that's when the plant gets degraded down as far as for availability, digestibility for the actual animals. So mature crops are not good for animals to consume. They're okay. They're not going to hurt them, but they're not there's not as nutritionally based as, say, a younger plant, an immature plant, before they actually produce seed. So the goal is to try to maximize the retention of forage nutrients. So we want to try to harvest it where we get a good yield and also a good amount of nutrient levels within it. Because once it gets mature, it's old, it's harder made. They have to chew on it a lot more to get it through their belly, the animal's belly. So we try to find that perfect spot, like on any type of axis we're trying to look at. But when we look at forage yield is typically measured in tons per acre. Forage crops vary in their yield. So if we look at maybe, say, coastal Bermuda grass in our part of the world, we look at about 2 tons per acre. Is a good number. Even 2.5 or 3 is even better. But some of them are into the 15 to 20 tons per acre. If we look at silage, where we may take a standing crop like corn and chop up the whole plant and keep everything, we don't let it get real mature. We produce a seed head, but we take it and chop it up, and then we do that, we can get a higher amount of tonnage out of it. So we see some northern areas and southern areas, and we see a really big difference in the amount of tons per acre that they can produce per year. And quartz silage yields, it can be up to 30 tons per year across the board, across the whole U.S. Because we have some very great varieties of crops out there that are forage based. So they're designed and bred to actually produce more green stuff than more, let's say, an ear of a corn. It's not gonna produce an ear as big of an ear, but it's going to produce more leaf and more plant material. But forage quality, we can look at forage quality is the forage feeding value. So how well that animal can actually digest it and actually take the nutrients in. But there's 3 components of forage quality that really take it into. One is intake, how well they're going to intake it. Nutritional value, so how much nutrients are actually in there, and antiquity factors that we'll talk about here coming up. But intake is how much that animal is going to eat overall. That's a really big thing. If they don't like it, they don't eat it. And so you want them to, they're going to go eat the best thing available to them. If they don't have anything available, they're going to eat it. But in a perfect world, we want to give them a choice, and we want to give them a better choice. Nutrient value, the content or the content of the nutrients. We really look at protein and energy on forage quality, because that's what makes the animal's body grow and do good things. And then we took the antiquity factors, anti-quality factors, excuse me, I've been butchering that all day. But those are toxins that reduce palatability and livestock performance. So sometimes there's mold that can grow on forages that we really don't like. Cattle don't eat it, or horses won't eat it. Can cause some respiratory problems sometimes. It just kind of depends. Now, we need to think about when we actually harvest our forages. Depending on the crop is what really determines it, but maturity of forages affects yield and the overall quality of it. So the older it is, the higher the yield, but lower the quality. But the younger it is, the higher the quality. So it's a give and take relationship. But So if we think about that scenario, as forage matures from vegetative to flowering, forage yields increase, but forage quality decreases. So as that plant matures, putting on a seed head, it's kind of spent, it's done, it's not going to do anything, but our quality of that plant decreases. So producers, we look at development indicators to determine when to harvest forages. So, like if you're going to harvest wheat for silage or a forage crop, wheat will put out what they call a flag leaf right before the seed head pops out, and basically that's the optimum time to do that. To go and harvest it for a forage. But if we're going to harvest it for a grain, we're going to let it go ahead and mature out. So if we look at the effect of alfalfa maturity on yield and digestibility, if we look at the solid purple line, and we look down here on the bottom, this is the different stages of it. We see that forage yield goes up, 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 and up until we get to about that full flower stage, and then it drops down just a little bit because it's gonna drop a little weight in that plant overall. It's gonna start to dry out. But if we look at digestibility, we're at highest when that plant is growing, but then as far as the yield matter goes, and then we're going to start dropping on digestibility as that plant hits its sexually reproductive areas. So when it's starting to bud out, the first flower shows up, when the whole plant's in full flower and post flower. So probably about the best time overall to harvest would be right here at this intersection. Just to get the best quality out of there. You can harvest it up here. We just got to know we're going to have a little bit lower quality because of there. We could harvest in this part of the world, but we're going to have less yield. So we're trying to find that middle ground to get there. So as we look at some developmental stages of actual crops, and we have forage legumes, so like our alfalfas, our clovers, things like that, and then we have forage grasses. So in this part of the world, we were looking at cline grass, any type of the Bermuda grasses. There's a couple of there's a lot of native grasses out there. We don't bale them for hay, but they're still considered a forage. We go through these and we try to really figure out what's the best spot for us to try to hit for us for harvesting those overall. But we can, a lot of our forages, like I said before, we really want to try to graze the lands, and grazing lands are ag lands with plant material that is suitable for grazing livestock. We can't grow crops everywhere. If you drive around CTC behind the hospital, you're going to notice that there is a lot of country over there, and we can't farm all of that. You couldn't plant wheat there. You couldn't. The soil isn't right. There's too much slope. We'd have a lot more erosion. So we graze it. But we have two different types of our grazing lands we try to talk about. The first one is pasture, and these are grazed lands on which either annuals like a oats or a wheat are put out, or a perennial forage are grown. So if we look at alfalfa, or we look at any of our Bermuda grasses or cline grasses that are out there. Now, rangeland compared to pasture land, the biggest thing is rangeland have native species that were native here before man showed up. Typically, those natives are a lot tougher. We don't get as near as much tonnage out of them, but we still get enough to raise livestock, so we have to manage them a little bit different. Usually, and it's not all one monoculture, so just one plant out there. Usually there's several different species of plants. Some start growing earlier in the year, some start growing later in the year, and that's why it makes it a great rangeland scenario. And basically that's what would have been back when the buffalo were here, right? The buffalo were still grazing. That's what we try to consider as our rangelands. But if we look at grazing is basically the direct utilization of forages by grazing animals. So grazing systems, we have a couple of different ones. Continuous grazing, where they have full access to everything the whole time. or rotational grazing. And there's a lot of benefits out there for rotational grazing, but animal performance on pastures is greatly influenced by the stocking rate, basically the number of animals per acre. Now, if you're looking at native ground in this part of the world, like we have over behind the hospital, you're going to be looking at a cow per 20 to 25 acres. But on a improved pasture, so like a Bermuda grass or a Klein grass, you could be looking at a cow per 5 to 6. I've even seen people go a cow per 3 acres in an intensive situation and do just fine. But it's a lot more management strategy that goes into that. And this is somewhat what I mean by management strategy. So you see the cow and the calf up there, continuous grazing. They have access to everything all the time. It's up to them to go search and find the best out there. A theory out there that works decently well is what they consider strip grazing. So right here in this bottom picture, you see a cow, and these are all fences. Okay, and so basically, you let them have this strip, and then you move them to the next strip, and you take this fence out, and you do that until they get across the whole pasture, and then you move them somewhere different. A lot more labor intensive, moving them, all that kind of good stuff. And depending on your pasture size and number of animals, depends on how often you got to move them. But if we look up here at rotational grazing, which is very popular in this part of the world, is we have all these fences. Well, they stay in one paddock for a certain amount of time or some management strategy. Let's say we take half the plant and leave half the plant. So we're out there measuring how tall our plants are, how short they're getting, and then we move them to the next. And we just do that on a consistent basis, giving every pasture or every area some type of rest to grow more plant material. More plant material equals more roots, equals better in drought situations. And then here we have creep grazing. We don't do a lot of this in the U.S. You see a lot of this over in the U.K. and over in Europe. But basically the cows graze over here. And then the calves have an option to go graze maybe some higher quality forages that the cows don't have access to. We're trying to set those calves up for success and try to put a lot of weight on them. So you want to give them the highest, most nutrient dense forage out there to help them grow and even take some pressure off their mom for their milking ability. But if we look at the relationship of pasture and production per animal and per acre, as we see the available pasture, as we see that number, we gain up, and then we start to fall down right here whenever we start looking at how much they gain per acre. So we really like that low to medium time frame for us to get there. But when we look at the purple line, the production on the production side of it, this is where we have a lot of great forages, high quality forages, and we get a lot more weight on those animals as far as that's concerned. Now, another way for us to harvest a crop is to produce hay. That's a type of forage that we can give to livestock, but we store that forage for the livestock for when the pasture is not available, like I mentioned, in a drought situation or in the winter when we don't have any actively growing grass out there. But most of our forages, when we harvest it and we cut it near the ground level, just like you'll see in the next picture, that's 80 to 90% moisture. We effectively, in our part of the world, we don't make much silage, but we typically, that would not store very well. So we dry it in the field for 1 to 5 days. And then once it's dried, we package it or bale it, essentially, and make a nice little pretty bale. Big square, small square, big round, just depends on what you're used to handling. And we bale it in the field, and then we store it in a dry barn, keep the rain off of it. Hay will keep every nutrient value it has at the time it was harvested if it stays dry. You put hay in a barn, as long as it stays dry and the rodents stay out of it, that hay will stay premier, just like you harvested it the entire time. It won't degrade, it won't lose any of it. It stays there. so it has a really good storage life, shelf life on it for the actual animals, as long as it stays dry. So here is a tractor, has 3 cutters on it actually. And you see the rows. Basically, they're cutting that alfalfa down at the ground level, and they're going to lay it on the ground. And then we're going to let it sun cure. And as it sun cures, it's going to actually increase the vitamin D level in it. And as it dries, it makes it a lot more palatable, and makes it to where we can basically store it, and it doesn't mold on us, or doesn't it could catch fire sometimes, too much moisture. But just a great opportunity for everybody, for the plant for us to store it a lot longer. So here on this chart, just a very detailed chart, but it has a lot of information on it. So main thing I want you to pick up, here at the top you have 2 different types of things we can do with forages. We have silage, and then we have hay. Well, if we look at that, we see that there's an unsafe area for hay or silage. There's not enough moisture to make silage, and there's too much to make hay. So you have to know what you're going to do before you start even producing it, because there's different equipment involved with it. But here we have this is what we call direct cut. We cut it and lay it on the ground, or wilted. So we cut it and lay it on the ground and let it dry a little bit, and then we do the haylage, where we cut it, dry it out a little bit, and then we chop it up some more and do that. But we see on the direct cut, we have a lot more storage loss from it there. But on the hay side of things, when we let it get really dry, that 20 to 10% moisture, if we look at that harvest loss, that's very big, a lot more on the hay side. So you're going to lose some no matter what, just because it's all mechanical. We can't really we have some finesse, but not a whole lot. But we just got to know we're going to lose some. You're not going to ever produce 100% of your crop. You're going to leave something out there all the time. But a little bit more on silage. Silage is a high moisture forage. It's stored anaerobically in a specialized structure, and I'll show you some of those. But our field losses are much less than haymaking. Basically, because we have all the moisture to keep all the plant material and structure together, it doesn't dry up and get brittle. Just think about when you pick up an old brown leaf that had fallen off a tree, and you put it in your hand and it crumples up like nothing. Well, if there's more moisture in it, as in a green leaf, crumple it in your hand. It's going to stay together. So it's that same type of mentality. Corn silage is very big. A lot of dairies use it. And then we also use hay crop silage, where we direct cut it straight off to the ground and harvest it. We dry it a little bit, then harvest it and pick it up, or we do haylage, a little bit different process. But silage has a great application in a lot of different areas. We just don't do a lot around here. You see a lot of feedlots up north, cattle feedlots, and a lot of dairies use it quite a bit. So here's 2 different ways that we actually store silage. So these are basically big small round bales, and we just put them in a bag, and we seal them up, and we let the bacteria go to work and produce that product for us. Here, in these big silos, there's a blower down here, and they dump it out of the tractor once they pick it up out of the field, and it blows it up here and stacks it in here. And then it goes through its fermentation process to make it more palatable, and that's the way we store it. And then they just pull it off the bottom, and it falls down as they pull it off, and feed it to the animals. Here we see some hutches with probably some dairy calves in them. Making it this is probably a pretty good dairy. This blue one right here is just a lot more modern style type silage storage. Now cotton, this will be our last slide for the day. Cotton is a little bit different beast. We don't use a combine, we use a picker or a stripper. But basically we harvest cotton when the cotton is mature, and the cotton bolls have opened up to reveal the white fibers. So right here, these are the cotton bolls that have opened up. And so if you ever drive, we have some cotton in our part of the world. So if you ever drive down a county road or farm to market road and you see the cotton, it'll be green up until this point. And then all of a sudden we start to see white showing up. And that white is the actual cotton itself. But a lot of times, so we can then produce our quality of cotton, we actually defoliate before harvest. And what we mean by that is we actually spray a herbicide on it to make the leaves fall off, because we want that cotton to be as clean as it can going through the process. The cleaner the cotton, the more the farmer can get on a price per pound basis, as well as we provide a lot better product for the industry to produce clothing that we put on and wear every day. So we want to produce that high quality product. Now we use a picker and a stripper. We're not going to go into the difference, but one of them basically kind of grabs the boll and pulls it somewhat a lot cleaner, and then a stripper will actually take the whole boll off the actual plant. So there's different varieties for both that are better for the picker or the stripper aspect. So the way you harvest it matters, as well as the products we use on them to defoliate, because we do have some that help open up bolls. Let's say our bolls are open up maybe a little slow. We do have some products we can spray on there to help open it up a little bit to get it out there. But once cotton is harvested, it's usually packed and arranged into modules. Now, in this day and age, they actually have a cotton machine that it's a picker, and it actually rolls everything up into these big round bales now. So back in the day, you'd see these probably 30-foot long by 15-foot tall, big square bales out in the middle of a cotton field. Well, now they're all round bales. They've just changed it. One machine, less machinery, less labor. Machinery costs more, but it's less labor, and they never have to stop. So it's an advantage. But cotton quality is, we really determine cotton quality by uniformity in length and color and the softness of fiber. Now, the USDA, the United States Department of Agriculture, actually grades every bale of cotton to set its marketability, how much money the farmer can make off of it. And so cotton farmers don't get paid typically until their cotton is sold, until somebody buys it and wants to go make clothes out of it. That's when they get paid. So it's a lengthy process. So you may harvest cotton and you may not get paid for a long time. So that's why cotton farmers stick their neck out quite a bit. Well, that's all I got for you today. Hopefully that was interesting. If you got any questions, shoot me an email on Blackboard or an email. Look forward to hearing from y'all. Hope everybody's staying safe. Thank y'all very much.